Okay, so we're going to look at two special right triangles. There are only two out there. You may have encountered them before, but we have a little more background and we're going to apply that. And to introduce the first one, we're going to start with a square. And you remember what the definition of a square is? All sides are congruent and all angles are congruent. And in fact, we know the angle measurements are 90 degrees. Okay. What's another name for a square? Well, another name that, true, it is a rectangle, but a rectangle's not everything, right? What's another, yeah, equal, that'd be rhombus, right? So it's, what name would say rhombus and rectangle as well? Yeah. Quadrilateral means four sides. Well, not regular quadrilateral. Okay, regular means that the sides and the angles are the same, and quadrilateral means there's four. So regular quadrilateral is another name for a square. So if I draw a diagonal, does it bisect those angles? Are you sure? Yes, why? The property of a rhombus. Good. So we know that this is 45 degrees, and this is 45 degrees, and so is this. And it creates these two triangles. Are the two triangles congruent? Yeah, by definition of congruent, like all three angles are congruent and all three sides are congruent. Yes, those are definitely congruent. And it creates this 45, 45, 90 right triangle. So I'm going to draw one of those 45, 45, 90s. And I'm going to make the hypotenuse 1. So if the hypotenuse is 1, let's let the side lengths be x and x because it's isosceles, right? So what is the length of x? How would we find that? Yeah. The Pythagorean theorem. What do you mean? So Pythagorean theorem says that x squared plus x squared would equal 1 squared. Right? A squared plus b squared equals c squared, where c is your hypotenuse, right? The longest side. And your hypotenuse is always across from the 90-degree angle. That's why I know that 1's the hypotenuse. So what is x squared plus x squared? What? No. What's x squared plus x squared? What is it? 2x squared. Yeah. 2x squared. So when you add like terms, they both have the same exponent. You just add the coefficients, the invisible one. So 1 plus 1 is 2. Okay. You don't change the exponents when you're adding. And so I want to solve for x, so I'm going to divide by 2 now. So I get x squared is 1/2. And I want to get rid of the square, so what do I do? Take the square root. Now we're going to assume x is positive because it's a side length. But if x wasn't positive, then if we didn't know it's a side length, x could be positive or negative because we're squaring it, right? And so that would make it a little more difficult. But we know x is positive, so when we take the square root of x squared, we're just going to get x. And we're going to take the square root of 1/2. And how do we do that? That's back at Unit 1. Good review for our final. We can't leave it like that because the 2's in the denominator, right? Okay, so you could split it up to square root of 1 over square root of 2. Square root of 1 is 1, right? Square root of 2 is, we don't know. Okay? It's irrational. And so then you multiply top and bottom by root 2 over 2. Root 2 over root 2. And you end up with root 2 over 2. Okay, so that is the length of x. Square root of 2 over 2. All right. So in our notes, we're going to put those lengths. So we have our hypotenuse is equal to length 1. Our legs are both the same length at root 2 over 2, which we just solved for. I'll put it in the picture here. And this triangle what was our last unit on? Similarity. This triangle is similar to all 45, 45, 90 right triangles. Why? By angle-angle similarity, right? That was one of the things that we studied. So whenever you have any 45, 45, 90 right triangle, you know it's similar to this one. So this is one that you're going to have to remember these side lengths. You have to remember the hypotenuse is 1 and the sides are both root 2 over 2. And once you have that, you don't have to remember any other thing about 45, 45, 90s because they're all similar to this one. So there's a proportion that we can use, or we can use a scale factor. So let's see what that means. So number 1 here, we have a 45, 45, 90 right triangle, and we have 2 missing values. Maybe one of them would be easy to come up with. X is 8. Why? Well, yeah, it's the converse of the isosceles triangle theorem. Yeah, you're right. So, and then we could come up with y without even doing this. We could use Pythagorean theorem, huh? So you could do that, but I want you to practice using proportions. So what we're going to do is draw our similar triangle. So we're going to very important that you orient it in the same way. So put the 90-degree in the same spot, 45 is in the same spot, but it's not the same triangle. It's our triangle, so hypotenuse is 1, and root 2 over 2, root 2 over 2. Okay. And so we want to know, well, how do we could set up a proportion to solve for y, or we could look for a scale factor. Okay. So if I were to look for a scale factor, I would think, well, what do I need to multiply root 2 over 2 by to get 8? And if that seems like, yeah, I don't want to do that, it's not so obvious, you don't have to, and that's fine. So you're going to say, let's just do proportion on this one. So these definitely correspond. And then I want to solve for y, so y is going to correspond with the 1. And so I'll set up a proportion and say 8 over root 2 over 2 is y over 1. And different ways to solve, but I'm going to cross multiply. And I'm going to get root 2 over 2 times y is 8 times 1. I'm going to get rid of my fractions, so I'm going to multiply both sides by, just want to get rid of the fraction. I'm just going to multiply both sides by 2. Because when you do that, because that's my denominator. So if I multiply both sides by 2, I can reduce that fraction there. And I get root 2 times y is 16. And then I'm going to have to divide by root 2. Or, yeah, I'm just going to divide by root 2. There's lots of ways to do this. But let's divide by root 2. We get 16 over root 2. Can't leave that root 2 in the denominator. So multiply top and bottom by root 2. And we get 16 root 2 over 2. And then you reduce that, which is 8 root 2. 8 square root 2. And that ends up being our scale factor, right? Because that's what you multiply by 1 to get y. So I guess if you just solved for your scale factor, that would also work. But 8 root 2 is what you want. So try number 2. Number 2 is a lot like number 1. Solve for x and y. So number 2, what are we getting for x? 25 root 2, yeah. And for y, you get 25. Now, number 3 is going to be a lot easier to work with. And let's look at why. So number 3, again, we have this 45, 45, 90 right triangle. And I'm going to draw mine, orient it the same way, put the side lengths, the 1 is the hypotenuse, root 2 over 2 is the legs. And here, it's a lot easier to see what the scale factor is. Like, what do I multiply 1 by to get 19? 19. So going from small to big, our scale factor is 19. In other words, the larger triangle is 19 times bigger than the smaller triangle. So if I want to find x, I know that corresponds with root 2 over 2 here. So I just need to multiply by 19. Okay, so how does that look? Well, 19 times root 2 over 2, well, I need to change 19 to a fraction, so 19 over 1. And you multiply the top with the top, bottom with bottom, and you get 19 root 2 over 2. And we found it. That's x. Okay. Y is going to be the same, right? Because it's an isosceles triangle. So here I didn't, on number 1 and number 2, I used proportions, because we could do that when triangles are similar. But on number 3, I'm using scale factor. Right, so that's your 45, 45, 90 right triangle. That's one of the 2 special right triangles. There's one more, the 30, 60, 90. And to give you some background of where that comes from, we start with an equilateral triangle. What's another name for an equilateral triangle? What is it? A regular triangle, yeah. So we're going to make all side lengths 1, because we know equilateral means all the sides are the same. We also know something else about this triangle. What? All the angles are 60 degrees. Okay, let's start with that. And then I'm going to draw an altitude. So an altitude goes from a vertex, and it's perpendicular to the base of that triangle. Does that altitude bisect the angle at the vertex or not? Does it have to? Well, I would say it does in this case. Anybody come up with an argument of why it has to split it to 30 degrees and 30 degrees? Okay, so we have the same distance here. Keep going. You're trying. No, that's it. Can anybody argue that the triangle on the left is congruent to the triangle on the right? That would be a good argument, right? Yeah. Why? Angle side. They both have a 90-degree angle. They both have a 60-degree angle, and they both have a side congruent. So the two triangles are congruent, meaning that, hey, this angle here has to be congruent to this angle. And if it's 60, well, there's only one way to do that, 30 and 30. So that would be our argument. How about the base length here? Has to be congruent to this one because the two triangles are congruent, so it has to be a half. Okay, so from that, I'm just going to now break this apart and look at one of the 30, 60, 90 right triangles. So we made the hypotenuse 1, but from this picture we found that the side length across from 30 is 1/2. We still are not sure what the side length is across from 60, but now we can find it by using Pythagorean theorem. So Pythagorean theorem says that x squared plus, which one should I use? 1/2 squared is equal to the hypotenuse squared. What's 1/2 squared? 1/4. 1 squared is 1, but I'm going to change it to 4/4 because I know what my next step is going to be. And I need to subtract, and I need common denominator to subtract. And so what's 4/4 minus 1/4? 3/4. So x squared is 3/4. Is x going to be positive, or could it be negative? In this case, no, because x is side length, right? In this equation, x could be negative, right? Because you square negative, you get a positive, or you square positive, you get positive. Because of the context, we're working with a positive value for x. So x is going to be the square root of 3/4, which is the same thing as the square root of 3 over the square root of 4, which is what? Square root of 3 over 2. Okay. A little easier to get rid of this square root in the denominator because we know the square root of 4. So we found our third side length. And so those are the three numbers we're going to have to remember for the 30, 60, 90. The hypotenuse is 1. The smallest side across from the smallest angle is 1/2. And then the side length across from the 60 is going to be root 3/2. We're going to put that in here. So hypotenuse 1, that's across from the 90-degree angle. Across from the 30 is 1/2. Across from the 60 is root 3/2. So hypotenuse 1, the shorter leg 1/2, longer leg root 3/2. And this is our 30, 60, 90 right triangle. And this is going to be similar to every 30, 60, 90 right triangle out there. Now, some of you may be thinking, hey, Mr. Marsh, you could pick some nicer numbers than that. Like, why are you picking fractions here, right? Like, you could do root 3, 1, and 2. And I could, but you have to trust me on this. I know where we're headed, and we're headed towards right triangle. angles with hypotenuse only 1. You'll see why tomorrow with tomorrow's lesson. And when we get to the next unit, that's when you're going to really appreciate it. You memorize this, because it's going to come up again. So if we didn't memorize this one now, we'd have to memorize 2 different kinds. So let's just memorize one kind and keep using it throughout the unit. So just trust me on the fraction part. So just want a little thing there. So let's look at number 4. So 30, 60, 90, because all 3 angles have to add up to 180. We got our 90 and 60 already. We're going to draw our 30, 60, 90, oriented the same way. Hypotenuse 1, across from 30 is 1/2. Across from 60, root 3 over 2. I want you to have that, work on memorizing that by tomorrow, okay? As you're doing homework, because this is all you're doing for homework. So memorize that, and it's not too hard to memorize. So then, easiest way, if we can, is to find a scale factor. If we can't find a scale factor, then we use proportions. Both work. And so we have one value here, and that corresponds with this value. And so the question is, can we figure out what our scale is here? 1/2 times what number is equal to 5? And if I multiply both sides by 2, I get my scale is 10. So I know, okay, this triangle on the right is 10 times bigger than the triangle on the left. So on the left, the hypotenuse is 1. So on the right, the hypotenuse is 10 times bigger. On the left, the side across from 60 degrees is root 3 over 2. So on the right, that's going to be 10 times that. So 10 times root 3 over 2, which can reduce to what? 5 root 3. And we're done. We found our missing link. So we got 5 root 3 and 10. And so the scale factor really cuts down the work if you could find it. Okay. And most of these you can use a scale factor on. There's one where it's just harder to find it, but most of these will work this way. Okay, so let's try the next one. Well, you try the next one. This next one's a lot like number 4. So did you guys find the scale factor? What's the scale factor here? 28. Good. So going from 1/2 times what equals 14, you can find that the scale is going to be 28. So that means x is going to be 28 times 1, and y is going to be 28 times root 3 over 2, which is 14 root 3. Okay. Number 6, similar to what we were doing. This time, though, we are given the hypotenuse. It's actually going to be easier because our hypotenuse is 1, and so even easier to find the scale factor. So what's our scale factor here? 32. So what's x going to be? Half of 32. So 32 over 2 is 16. And y? 32 root 3 over 2, so 16 root 3. All right, 7, 8, and 9. Finish it off. So which one was hard to use a scale factor on? Definitely 8. 9, I'll show you how to use a scale factor. But I mean, you could use a scale factor on anything. Sometimes it's more natural to use it on, like something like 7 would be not too bad, just gives 46. But 8 is definitely not natural to use a scale factor. So I use a proportion, and let me show you. So on 7, x should be 23 root 3, y should be 23 because the scale factor is 46. If you in your work, if you're going to use a scale factor, then I need you to state what the scale is, like I am. Okay, so whenever I use a scale factor, I write scale is 46, and then I know where things are coming from. Okay, make sure if you're going to do that, that's kind of your ticket to do that. If you use the other way, then you need a proportion, right? So that's what I'm doing on 8. I'm setting a proportion. Solving for x, I use the black ink here. Solving for y, I use the green. You get 40 root 3 over 3 and 20 root 3 over 3. Did anybody do the scale factor in number 8? What was the scale factor? Yeah. So you get, so this ends up being your scale factor here, because you're going from 1 to that number. Was it less work? No. About the same or harder? About the same. Okay. And then 9 actually is not too bad to use a scale factor, and that's what I did here. But you don't have to, because it is, at first you're like, I don't know what it is, because you got to go from root 3 over 2 to 9 root 3. But if you look at my work here, that's how I solved for the scale, and I got 18. And then once you have that, then it's easy to find x1. But just know, scale factor can be useful sometimes, but you don't have to. Proportion is also useful sometimes. So I'll leave this up here for you to copy down. If you have questions on it, please ask. I passed out your homework to you. The homework is, I did not give enough room for you to do your homework on that paper. Okay? So homework for this unit needs to be on a separate sheet of paper. And when you do the homework, you number it, you draw the diagram, which shouldn't take much time, and then you solve it. Okay? And remember, we're submitting our homework to Gradescope. Okay? Yeah. So you have the remainder of the period to work on homework.